Hi everybody, welcome to this video looking at condensation polymerisation and the formation of polyesters. If we start off with what a polyester is then, they are a different type of polymer than you will be used to. They still form when two monomers join together, but with this type of polymer it involves the elimination of a small molecule such as water. Now an example of a polyester is PET, polyethylene terephthalate. Now you may not have heard of this polymer before, but it is extremely common and is used in plastic bottles. The reason for this is that the polymer is strong, lightweight and shatter resistant, and it can also be used to recycle it and turn it into plastic garden furniture, carpets and fleece jackets. So now you know what an example of a polyester is, you need to know how they form and how you can draw the structures of them. For example, polyethylene terephthalate, which we have here, even though you won't be asked to draw this one or anything this complicated. The first thing to know when drawing a polyester, which is an example, as I've said, of condensation polymerisation, is the functional group. The ester functional group is a carbon bonded to two oxygens, as you can see here. So let's react ethanoic acid, CH3COOH, with ethanol, C2H5OH. When these two chemicals react together, the hydroxyl group from the carboxylic acid and the hydrogen at the end of your alcohol get removed, and they form water, thus the name condensation polymerisation. The oxygen on the alcohol then bonds to the carbon on the carboxylic acid, and you get a compound that looks like this. Now the name for this compound is ethyl ethanoate, CH3COOC2H5, and I'll explain how I got to that name in a minute, but all you need to know is the byproduct now that is made, which we spoke about earlier, is water, H2O. So how would you draw this in an exam? If I were to change my diagrams, ethanoic acid will look like this, and ethanol will look like this. So when you go to draw the polyester, you will see from the colour coding that I've used here how to draw it. The green section is from my carboxylic acid, and everything but the OH group, and then the purple bit is my alcohol minus the hydrogen attached to the oxygen. Now this colour coding that I've done here, this helps you to name the carboxylic acid as well. So the ethanoate bit is from the carboxylic acid. So change ethanoic into ethanoate. And then the ethyl group is from the alcohol. So change ethanol to ethyl. Now this can seem a bit complicated, so let's go through with another example. This time I'll react butanoic acid, C3H7COOH, with propanol, C3H7OH. So start by drawing out your carboxylic acid with all the covalent bonds, as you can see here. Then draw your alcohol out. It's easier to draw the hydroxyl group on the left because you can see where they will bond together. Now you know that the OH from the carboxylic acid will be removed and the H from the alcohol as well. So redraw this and join up the two parts. Join up the oxygen from the alcohol to the carbon with the double bond O on. This will be your final structure here. To name it, take the name of your alcohol, propanol, and change the ending from anol to -ul, so propyl. Then take the name of your carboxylic acid, butanoic, and change the ending to ate, butanoate. This gives you the name propyl butanoate. And then don't forget to draw the structure of your byproduct, H2O. Okay, that's how to draw them. But is this actually a polymer? The answer to that is no, because we only have two monomers joined together. So when we look at drawing the actual polymer, what you will have is two functional groups on each of your reactants. Ethanoic acid monomers will have two carboxylic acid groups, and ethanol monomers will have two alcohol groups. Now all you do is the same. Remove the OH from the carboxylic acids, and then the H from the oxygen on the alcohol. The polymer will then look like this, and all you have to do is draw a bracket around the bonds with no atoms attached, which looks like this. From the diagram you can see that the carboxylic acid is here, and the alcohol is here, giving you a repeating unit of a polyester. Now I understand there's a lot to take in there, but that is all you need to know on polyesters and condensation polymerisation. If you're unsure on anything, go back, watch the video again, try and take in all the steps that I've been through. Let's have a look at a few questions, have a go at them, pause the video and we'll go through the answers when you're done. Okay, let's go through. Question 1. What is PET used for? Answer, plastic bottles for 1 mark. And then what property makes it suitable? They are either strong, they're lightweight, or they're shatter resistant. Any one of those three gets you your second mark. I'll also accept that they can be recycled, turned into carpets, fleece, or plastic garden furniture for a mark. Question 2. So we have propanoic acid, C2H5COOH. Draw that out like this below. Then we have methanol, CH3OH. Again, draw that one out this way. Remember, you're removing the OH and the H here, although don't cross this out in the exam, and then joining them together. So this is your carboxylic acid section, this is your alcohol section, so methylpropanoate should look like this. You'll get 1 mark for drawing the reactants out correctly, 1 mark for drawing out methylpropanoate correctly, and then 1 mark for your byproduct, which is always water. Now you'll notice I've made a mistake here. The water should be the structure, 1 oxygen attached to 2 hydrogens with the bond showing, not just H2O. So don't make that mistake yourself. And that really is it for this video. So I have got a review question for you. Have a go at it, and the answer is down in the description below. Hi guys, hopefully you found the video useful. If you did, please click on like and please subscribe to my channel. If you've already done that, please share with your friends, share with your teachers, any way that's going to help me. I've also got a website with loads of videos that can help you, and there's also my latest video appearing on the screen now. Thanks for watching.